Hello, guys. Welcome back. Good evening to all of you. And it's not good evening, almost good night. But still, let's do today's problem. And if you have not solved the problem of today, please stop the video. What's like, do it yourself, and then afterwards, what's the solution, whether it matches with you or not. So let's get started. Let's dive into the problem right away because we are all really hungry. So let's get started, guys. So a box contains 2016 balls, which are level from 1 to 2016, and x1 is the level of the ball that is picked up by in the first go. That's like all of those 16 balls are there, and then after that no balls are returned back to the box, so it's done again. X2 is being pulled up, another level of the, like, another ball is taken out of the box without replacement. So there's 2015 balls, so it's dependent. Okay, so it's x2 is dependent upon x1. Whatever you have picked out of x1, x2 is dependent upon x1. That means x2 will not get out of, like, if x you have picked out x1 is equal to 2, then x2 will never take the value 2. So therefore x1 and x2 are not independent, they are dependent upon each other. They are dependent upon each other. Okay, that's the first criteria of the understanding. And let's compute this one by one, like using the laws of, like, using the results we know. So let's first calculate probability x1 less than x2. So how do you calculate it? So first of all, x1 is comes first, and then comes x2, right? So if that happens, so let's first condition on x1. So we need to find probability to x1 less than x2. So we can condition on x1. So by law of total probability, we get probability x less than x2 given x1 is equal to x into probability x1 is equal to x. Okay, and x is going from 1 to 2016, all the values it can take, right? So x1 can take all the values from 1 to 2016. So this is how it's related to each other. Okay, and it's how related to each other, and let's compute it. So if uh, we have picked up x1 is equal to x, so what is the probability that x2 is greater than x? Okay, so there are 2015 balls now. The probability that x2 is greater than x is x1, x, it starts from x1, x plus 1 dot dot 2016. So it's 2016 minus x plus 1, okay, plus 1. So this is the number of balls, number of options we have if x2 is greater than x, into probability x1 is equal to x. So initially it's like uniformly distributed, so it's 1 by 2016. So this is 2015, I'm so sorry. And summation of x from 1 to 2016. So we get that it's summation of x from 1 to 2016 minus x by 2015 into 2016. Okay, and if you see, it's summation of 1 to in 2016, 2016, so it's sort of 1 plus 2 plus 2015 by 2015 times 2016. If we calculate this n into n plus 1 by 2, it turns out that it's n into n plus 1 by 2, so it's half. So it's not greater than half, it's actually equal to half. So I still didn't find out an intuitive understanding of this, but if you can find it out, because it's night and it's not coming through my mind now. So if you find it out, let us know in the comments. Okay, so let's compute the expectation of x2, like conditional expectation. It's very easy. So expectation of x2 given x1 is equal to 108. This is what? So how do you calculate this? So given that, so x2, first understand the distribution of x2 given x1 is equal to 1008. So it follows uniform, discrete uniform over 1, 2, 100, 1007, and then 1009 onwards to 2016. So 2015 balls are there, so it follows discrete uniform on that, right? And therefore, expectation of x2 given x1 is equal to this will come out to be what? Will come out to be sum of all these numbers, 1 plus 2 plus . So everything 2016 by 2016. But ऊपर में क्या होगा? ऊपर में minus 1008 is there because you have counted it once over here when you're adding up till 2016, and there are 215 balls, so you divide it by 15. And you can calculate this now. And let's calculate it. So you get 2016, 2017 by 2. So you get 1008, 2017 minus 1 by 2015. Am I doing it correctly? I hope so. Yes. So you get 2016 and 2008 by 2015. And you get that 2016, 2008 by 2015. And essentially that's greater than 1008. Okay. And that's greater than 1008. Yes. So that's the idea. That's the basic idea. And yep. So that's greater than 1008. And let's calculate expectation of. So all these things you can individually try to figure it out why this is true. Okay. For the last one, we will use something called smoothing property. So expectation of x2. So we know the behavior of x2 given x1 is equal to x. So what we will do is that we will do expectation of x2 given x1, uska expectation, and this will give rise to expectation of x2. And already we know expectation of x1, which is what? Which is 1 plus 2016 by 2016, discrete uniform. And it turns out to be 2017 by 2. Okay. And let's compute it here. So x1 follows discrete uniform, so that's why this happens. And let's follow it here. Let's understand it here. And if you understand it, that let's calculate x2 given x1 is equal to x. We have already found it out. So if you do it over x, it will be what? It will be minus x over here. Everything will be, rest will be remaining the same. So what we get over here, expectation of this will come out to be 2016, 2008, 1008, 2017 minus x1 by 2015. That will be the idea. And let's check it out now. Now expectation, this will turn out to be Bahar. So it turns out that it's 2008, 2017 minus expectation of this, which turns out to be this, x1 by 2015, by applying the laws of expectation. And we get from here that 2017 is common by 2015, and by 2 is also common over there. So we get that it's 2015 again by 2, which is equal to 2017 by 2, which is equal to expectation of x1. That is really good. So we have found out mathematically this is equal to expectation of x1, and expectation of x2 is equal to expectation of x1. So x2, yeah, expectation of x2 is equal to expectation of x1. So you think about it, why this is true and how it's coming out. I hope I have not done calculation mistake. Let me check once again. 16 minus 1, 15, 15, 15 cancels. Yeah, 2017 by 2. So I hope you understood the solutions. We use very important ideas over here. Adam's law, smoothing property over here, and we use all the important ideas of conditional expectation, conditional distribution. Yep, so that's very important. These are very important ideas that you need to develop your foundations in the subject and to develop your problem solving skills, guys. So all the best, guys, and good night. Stay tuned and stay blessed. If you're liking this regular problem solving, do show your support by liking and sharing with your friends who can get benefit for their preparation for free. All the best, guys, and I will see you in the next video. Stay tuned and stay blessed.